Hello everyone, welcome to my YouTube channel. Myself Nishan from Sri Venkateswara College of Engineering, Bangalore. Today we are discussing about insertion sort algorithm. Welcome to our presentation on insertion sort. A fundamental algorithm is a field of computer science. We'll discuss about insertion sort. Now we'll see the introduction. Introduction to sorting algorithm. First, what is sorting algorithm? A method of organizing a data element in a specific order. Giving correct input and getting correct output is called a sorting algorithm. Why are they important? Sorting algorithms are at the heart of many computer applications for searching through large database and machine learning. Types of sorting algorithm. There are many. First, we'll see bubble sort, quick sort, merge sort, and of course, insertion sort. Today, we are discussing about. Next, overview of insertion sort. What is insertion sort? A sorting algorithm that builds a final sorting list one element at a time by inserting each element at its appropriate places. Why it is called insertion sort? Because the algorithm works by inserting element into their correct position in the list. How does insertion sort works? Elements are compared against one another. If an element is further back in the list is larger or smaller, the current element is swapped into the place like a pin in a cushion. We'll see the example for insertion sort. Now we'll see the example. We will give the position for 4 as first position, 3 as second position, 2 as third position, till and 6 as last position. First, we'll check for first position is greater than or smaller. First, we have 4, here 3. Uh, we'll check it is greater. 3 is smaller. 3 is smaller than 4. That's why we are swap. If it is larger, we can't swap. uh, Next position we have swapped 3 and 4. Next we'll go for the third position as 2. 2 is smaller than 3 and 4. That's why we are shifting 2 to the first position. Next we'll see for 10. It is greater than 3, 4 and 2 and it will remain in the same position. And afterwards we'll see for 12. It is also greater than 10, 4, 3, 2. It will also remain same. Next we'll see for 1. It is smaller than 12, 10 and 2 everything. First we will shift to the first position. Afterwards we will see the 5. 5 is smaller than 10 and 12. We'll shift for the fifth position. Afterwards, we will see for last element as 6. We will see which position it will shift. And 10 and 12 is smaller and it will shift. After that, we will get this answer. This is called insertion sort. Next, how insertion sort works. We have seen the example. We'll see how step by steps. There are 4 steps. Select the first element and compare and swap. Insert the element. Repeat for each element. First, select the first element. Begin sorting by selecting the first element in the list. We have selected the list as 4. We have seen in the example. Compare and swap. The selected element is compared against one next to it. If there is a wrong order, they are swapped. Insert the element. The selected element in the compared against the rest of the element in the sorted position of the list and inserted into the correct position. Repeat for each element. We should do for every element we have inserted. Contain selected the next element sorted until all the elements are sorted. Next, we'll see the time complexity analysis of inserting sort. There are three: best case scenario, worst case scenario, real world scenario. The best case scenario for insertion sort is when the list is already sorted, makes the time complexity 0 of n, where is very effective. Worst case scenario. In worst case, insertion sort required of n power 2 times complexity, makes it less efficient than the other sorting algorithm for very large list. This O 0 of n power 2 is an formula for a worst case. We'll see a real world scenario. Insertion sort is often used in small to medium list, and its sub-algorithm is more complex sorting algorithm. Next, we'll see advantages and disadvantages of insertion sort. First, we'll see advantages. Advantages means a useful effect of small to medium size data sets require number of additional memory other than that used for original data. And we'll see the disadvantage: requires lot of swapping. We should swap. If we give 100 inputs, we should swap everything. That's why it is a disadvantage. Makes it less effective than other algorithm, as quadratic times complexity in the worst case scenario. Next, real world application of insertion sort, where we use, we'll see in library catalogs, sorting books in library, uh, price tags, sorting price tags on the clothes and accessories. Next, postal sorting, sorting in packing letters of zip code or address. Uh, this is about insertion sort. Thank you for watching.